All right, we have a good bit going on in here. I mentioned some of it yesterday. Probably mentioned all of it yesterday, but it's all worth repeating because it's a busy week. Homework drop dead deadline is tomorrow. Make sure you get something in if you haven't already. Thursday, we're going to be reviewing for an exam that we take on Friday. If there's anything I should know ahead of that, let me know. I can schedule you for whatever we need to work around anything. What else? It isn't quite as busy as in my next class. Like there's I have lots of announcements, and there's 3 or 4 of them for this class and 12 of them for that class floating around in my head. I think that's basically everything going on. This class is a lot simpler to manage than that class. It's nice. I don't think I could manage 2 classes that are that complicated. Any questions before we dive into or back into the pumping lemma? How do we feel so far about the idea of the pumping lemma? I know obviously there's going to be we need some practice. We need to see this actually work, but theoretically, how does it feel? Hard to know. Yeah,
in the middle.
Yeah,
it's making more sense the more I think it's
Too visualize.
Yeah.
It's too early in the morning.
But you had your caffeine. That's important.
Not enough.
Right? That looks like a very small amount of caffeine for this topic.
Yeah.
I should have hot chocolate.
It sounds like it needs caffeine. It sounds like it's perfectly set up for success, but it's just missing the key ingredient. I'm not addicted to caffeine.
It's kind of like a placebo effect.
Right?
Yeah.
I'm drinking something, so my body's like, all right, I probably have caffeine, so I'm just gonna react like I am. Kind of like right about before you're gonna put an acidic food in your mouth, your body's like, all right, I am ready for this. It starts producing that
The saliva.
the saliva, the really basic saliva to mix with the acid so that it's better digestible. Yeah, exactly like that. So the last time we talked about, well, the end of last class, we talked about how the pumping lemma worked and then how to phrase it in terms of this game. I still don't know how much I like delivering this. So by the end of the quarter, I'd be interested to talk to you about how useful was the phrasing of this game in terms of developing your understanding and helping you to solve problems. But for now, it's really just a process that you can imagine the game being played between 2 players. Player 1 picks a value for the number of states in the DFA that accepts this language. Player 2 says, all right, you gave me that M, I'm going to pick a string of length greater than or equal to that, so that there are more characters in the string than there are states in the DFA that you assert solves this problem. Player 1 with that string chooses the decomposition of that string that adheres to the associated constraints, with the purpose of making this last step as difficult as possible for player 2. Then player 2 picks the number of repetitions of the loop, that Y portion of that string. And if player 2 can do that, then player 2 has shown that player 1 was unsuccessful at creating a scenario that could not be outside of the scope of a regular language. So our goal in this class is to prove that not just an instance of this game is impossible, but it is not possible at all for player 1 to win this game. From player 2's perspective, there's always something we can do to win the game. So this would be the least fair game in the history of ever if we actually choose a regular language for this. It's only if you choose a non-regular language for this, then player 1 has no hope of ever constructing something that's going to get around that idea where we can't show that it's not regular. But let's actually dive into a real example, because I think actually writing this out and seeing and showing that will help to make this process a bit clearer. We're going to start with a string called WWR, which is some substring followed by that exact same substring in reverse. Another way to think of this is an even length palindrome. Not every palindrome, because there are odd length palindromes that share that middle character. That's not part of this language. This language is just even length palindromes, where the first half is the second half reversed. The second half is the first half reversed. So if we're doing this in terms of the game, then the way that you would play the game is that player one picks a value of m. And this is not how you're going to do this in general, but this is again just how the game would be played. Player one picks a value of m, like 7. We probably want to choose something shorter than that in general. But player two, now thinking about whatever player one could pick, if you're trying to solve this game in general, you want to derive a formula for whatever player one picks. This is going to be our strategy for what player one picks. That's going to put it outside of the realm of what player one has any control over. So if we can come up with a formula for that, then whatever player one picks, we just plug that into the formula and that generates our string for us. So we want to pick a string such that the first m characters are all a's and w is of the form a to the n, b to the m. The reason we want this is because it's going to be very easy to prove. It adheres to both of those requirements, that the length of xy is all a's. So remember that we're going to, player one's next thing is they're going to break down this string into x, y, z that adheres to 2 constraints. So the reason we pick this is that we are pigeonholing them into picking an x, y that comes from all a's. So we have to pick a string that is at least m characters long. A to the m, b to the m is 2m characters long. So if player one picks 3, then the string that we pick is A, B, B, B. If player one picks 5, we would pick A, B, 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 B. We have to pick something that is in the language that is given. Sorry, say W, because then we have WR at the other end. So this would be B, 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 A. So there's your W, there's your WR. So it's really 4 m characters long. So now player one, because they have to break it down such that x and y are less than m characters in total length, where m, this would be the string that was generated if m was 3. Within the first 3 characters of this has to be the breakdown of x and y, and the rest of this has to be z. Why was that? Going back to some of the arguments that we had about the pumping lemma and about DFAs in general. Why does x and y have to come from this portion of this string? Yeah.
We have to see the loop before seeing all the states.
Yeah, because they picked m, the number of states in the DFA. So what player one was asserting when they picked this value of 3 is that we could represent this DFA in 3 states. So we're saying if any string of the form WWR can be represented in a DFA of 3 states, then we need to be able to represent this string, which is of the form WWR, in those 3 states. So because of this, and the way that we mentioned this before, we're going to have connections here that read an A, and by the time we read this third A, we've created our loop. Which means that getting to the loop and completing the loop has to have occurred within those first 3 characters. We've just selected a string type here of this form. By selecting this form, we guarantee that getting to the loop and completing the loop is going to happen within the A's portion of the A to the M, B to the M, before we go into the reverse B to the M, A to the M. How are we doing with that? Does that make sense? I see a couple of nods, a couple of hesitant nods, and a lot of nothing. Any further feedback on that? How can I help that make more sense? And or is it just I don't even know what you're talking about at this point, which is okay. I just need to know where people are to know where to go next.
I think I'm tracking. So everyone picks M and that determines the number of states, but then we could pick a palindrome much longer of the form like A then B, and then follow by that reverse.
Yeah,
And that explains why breaking it down into X, Y. Only the first three.
yeah,
So you have to run through at least 3 states before you.
Yeah.
I think I'm tracking.
yeah.
100% sure.
And we know that though in the worst case, all we can do is move to a new state, move to a new state, move to a new state. As soon as we see this third A, when there are 3